Welcome to this series of lessons where we look at geometry and how we can use SAP Variant Configuration to implement that geometry for common objects. So the next series of lessons we're looking at the cone. So if you like what you see, feel free to subscribe and like this YouTube video, and then you'll get notifications when we release the next one. So let's get started. We continue from the previous lesson where basically we're working with a diameter and a height, and with that we will be calculating the angle of the cone. Now we're adding to our model, so we're going to add some more characteristics. So we've got slant length, which will be used in a later lesson, so that's the hypotenuse of the triangle. Then next we will set up the characteristic to hold the calculated angle. So this particular characteristic will store the value that SAP calculates, and it's stored in radians, and we'll need to convert those radians to degrees. And so this characteristic will be the characteristic that will store the angle as degrees and with decimal points. Okay, so we're back to the fun part again. So we're going to create a constraint that will calculate the angles. So we'll just get to the editor. So the setup is sort of similar to the one we did for volume. So again, we comment what it does, and then we're specifying the object. So again, it's the class that we're using, and we're using the where syntax that just makes the formula a bit more easier to describe when we write that out in the restriction section. So we're setting up the diameter and height, the angle, which is the radian 1, and the angles for degrees, and we just also have pi, which is still important. So in the restriction section we start to define what we're doing. So we're using essentially tan from trigonometry, and also arctan really, which is the piece that converts it to an angle. So I'm not sure if my description of the formula is totally correct, but you get the idea. So the angle will be the arctan of the height divided by the radius, and radius for us is diameter divided by 2. And I'm just commenting exactly what is done there, and that the next section is where we're going to convert to degrees. So we use a formula again. So really we take our radian angle, multiply it by 180 and divide by pi, and that will give us the result. So we'll just release all that and save it. So let's test what we've got. So we go into the simulator, and so we will start by adding in a height. So I'm adding in 100 as our height, and I'm putting the diameter as 200, so effectively that gives us a radius of 100, and so therefore if it's 100 high, 100 radius, then it's a 45-degree angle. And as we can see, the result has turned out that way correctly. Okay, I've just added 2 more inferences for the diameter and the height. So what I'm trying to show here is the power of constraints. So by doing that, what we're doing is getting multi-directional determination, and this interacts with the other constraint that we created for the volume. So you can see in this case what I've done, I've started off with the 45-degree angles that we were calculating in this lesson, and then gone back and put in the diameter of 200 like before, and then just pressing enter on that, it calculates the volume and the height automatically. So it gives you multiple ways to enter the values and get automatic updates happening. So that's the power of constraints and the power of inferences. So let's just summarize. I just want to cover a couple of points. With the pi characteristic, just make sure you've got default ticked on, just so that that will actually work. Otherwise you might get some errors. Now, so we've got our two constraints now, one for volume, and that's relatively simple, and then we've got our other one for the angle. So you can see, just using essentially two dimensions, the height and the diameter, we can calculate the volumes and the angles just from those two values alone. And then we can see with the inferences how we can get the formulas to interact. So it's really, really powerful. So I just want to close off on that, and the next lesson we will start looking at the length of the slant angle, or the hypotenuse. Thank you for your time.